Okay, welcome back to another episode. All right, and at this point, we are still on the moments. Now, from the previous video, we're able to solve a particular question with some of the example or problem with this. Then, at this point, we also have another problem that we're going to analyze it together. So please let's pay attention with this. Get our pens, our calculators, and our book ready for this problem. Now, first of all, let's deduce this together. Now, it says that the rectangular plate is supported by the brackets at E. This is our E here, right? And B. So this it has been attached, all right? This is the brackets. And by a wire CB. So this is a wire. So knowing that the tension in the wire is 200 Newton, determine the moment about E. So this E here, all right, of the force exerted by the wire at C. So that means that about, so from this to the line of action of where the force is coming from. So from this, so from here to here. Now at this point, we can choose to name the place by the names. So we can make that the one that is vertical here should be our Y here, right? So let's choose another colors that we can use to indicate various direction. So we can say that from here going to this direction should be our Y. The one going to this side, so this is our origin. This should be our Z. Then this should be our X over here too as well. So in the direction going to this side is our X. In the direction that's going here is our Z. And this side is our Y here. So at this point, we are supposed to analyze this problem together. So how do you go by? So first of all, let's see. So that means we have to know that our moment is equal to the, the vector force multiplied by the what? The position. This time, all right? So that is it. Now here we know that the forces of this should be equal to our force multiplied by what? Our lambda here. We also know that our lambda is equal to, so if you're having this, we have xi plus yj plus zk on what? On square root of what? Of s squared plus y squared plus z squared over here. I think we are used to all these things. Then lastly, we can also use this method of saying that our moment, all right, so our moment is equal to, so let's erase this so that it becomes very simple for us. All right, so our moment is equal to um, the component of I, J, then K here. So we are having X, our Y, our Z of the R, and the last one over here as our FX, FY, then FZ as well. Now with this, we can also choose to convert all the what, all the parameters over here into what, into meters. So that means we know that 1,000 um here is equal to what? 1 meter. So that means if we have 300 here, you're gonna get what? So 1, 2, 3. You're gonna have what? 0.3, right? So let's use this to indicate so that it is very simple for us what to do it. So let's use this resistance here. So if you're having 300 here, so 1, 2, 3. You're gonna have what? So 1, 2, 3. You're having 0.3 here. If you're having our 8 cm here, so 1, 2, 3, so 0.08. This one's going to be 1, 2, 3, right? So 0.24. This to the same thing going to be 0.08. This 240 to be 1, 2, 3, right? So it's going to be 0. Okay, 0.24. Then lastly, we can say that we have converted all these into what? Into meters. It's very simple, right? Okay, I think by now you are part of it. So let's see how we can solve this problem together. So once we know this, all right, we can easily, all right, find for various what components from the forces. So we can say that now, since we know this here, let's find various direction at which it is moving. So that means if any direction is moving to this side, it's positive x. Any direction moving to this side is positive z. Any direction moving to the top here is what? It's positive y. Any um any reverse form of these various components becomes what? Negative, right? So we are having the main force here. So this is our F multiplied by the what? The lambda here. So let's find it for the lambda. We know that our force here was given. So from this side is 200. So we are having 200 over here multiplied by. Now let's find for this here. So you can see that this question is saying that determine the moment about E of the force exerted at C over here. So that means that if this one is exerted at this point, that means we are moving from here to what? To D here, right? So this is C. So determine the moment about E of the force exerted by the wire at C. So if you want to find the main forces at this direction, all right, that means where the force is going is moving from here to this side. And this at C, at which is exerted. So you're going to move from this side to what? To this side to as well. So that's the whole of it. So at this point here, we are going to see that our positive x will be at this side. Sorry, it's going to be at this side. It's the same as this one to this side here. But let's see something over here. Now we want to go to this side, but it's from C. This one is exerted at where, okay? So that means if it is here, C is this point, we are moving to this side, not here, from C to D. This is the direction. We can also choose to move from this side to this. At the end of the day, you're going to get the same thing. So moving from C to what? To D. So let's see. So if you're moving from this, you're moving in negative form. You're moving in negative 0. What? 0. So negative 0.3 here to be our I here. Then as we have gotten here, because this is same as is this, right? So now again, we are moving to this side also. But you can see that from here, we are having from here to here is 0.08. From here to here is 0.24, right? Before now we move to the Y. So our Z here is going to be 0, right? So you're having 0.08 plus 0.24. So that means at this point, what are you going to have over here? So that means that this is also the z direction we are moving. So I'm going to move in 0.3 what? 32, right? So 0.32 over here. Now, once we are done, don't forget you're moving in this side. So you're moving in negative z. So let me indicate it very well here. So the direction moving here is positive. Here is positive, plus, plus, then from here to this side, it's also what? It's also positive, moving up here. So any counter of it becomes negative. So this you're going to have, you're going to have negative 0. What? 32 here, key here, because this is our z. Then lastly, from here to the top here, moving in what? Positive form. This is the same as this. So you're having what? Positive what? Positive 0.24 here, key here. So that's what we are having here. So with this, we can really arrange them together. So what are you going to get? So if you arrange it, you're going to get negative 0.3 here as our I. Then we are having plus 0.24J. Okay, so this is the 4 here, J here. Then lastly, we're having negative 0.32 here as our key here. All divided by, don't forget this. So you square this. So if you square the whole of this, so that means at this point, I'm going to square the whole of this. That means I'm having negative 0.3 squared plus 0.2 squared, then lastly negative 0.32 here, all squared. So all in the square root. So at this point, we're going to have our f to be equal to our 200 here multiplied by, so the whole of square root of this give us 0.5. So you're having negative 0.3i here plus 0.24j minus 0.32 0.32k here on what? On 0.5 over here. Now with this, we can easily find the various components for this, right? So if we find the various components for this one here, so let's do it. So we're going to get our f to be equal to, so the whole of this 200, so we're going to have 200 multiplied by negative 0.3i on 0.5. Then we are having plus 0.24 on 0.5 minus 0.32 here on what? 0.5 here. Okay, J, then we are done. So you can easily multiply them together. So at this point, if we multiply this 200 here by this, we should be able to get various what? Various answers for all of them. So let's bring it to the top small. All right. Okay, so now we can easily multiply them by multiplying the 200 by what? The negative 0.3 on 0. What? On 0.5. So at this point, we're going to have our f over here, which is our the one from the what? The positive side over here to be our what? Negative 100 and what? 20 I here. Then we are having this 200 multiplied by 0.24 on 0.5. Then we're going to have this to be our what? Our positive 96 here. Then lastly, we are going to have this 200 multiplied 0.32 on this. We're going to have negative 100 and what? 128, right? Okay, over here, then bring our k here. Don't forget your j here, and we are done with the various components. So this looks like the same as fx plus the fy here. All right, then this is our the fz direction. So that's how we are supposed to get for. Now once we are done, we are supposed to look for what? Our r here. Let's look at it very well. This is where you're supposed to get our r here. So how do we get our r? So now at this point we can say that our r here, all right, our r vector or position vector here is equal to. So with this, we can also find it over here. Let's make it also arrange things. So we can say that at this point, if we are supposed to find the moment about what? About E, all right, about E, okay? If you're supposed to find a force from here to where the line of action of the force is starting from or is being exerted to, that means from here will be moved to this side here. So you can say that you have R here to be in a direction of the distance. So now that means you're moving from here to here to this side to where this one will begin. If you are moving this, that means you're moving positive what? Z, right? So if you're moving positive Z, you're going to have 0.0 what? E because it's in positive side. That is it. So you have our key here. Then the next one. Now we are also moving in this direction. This is equal to this is 0.3. So if it is 0.3 here, that means this is equal to this. So we have it plus what? Plus 0.3 what? 3i. Then lastly, you don't have any j here because moving from here to here. So that is all. So plus 0 what? 0 j here. Then we are done. Now once we are done, now let's arrange them together, starting from the xij. So you can see from the I, we had positive 0.3 I here. Then the j, we had 0 because nothing was happening over here. It was only in touch with only the z and the x. So we are having plus, what about z? We are having 0.08 over here k. Then we are done. Now once we are done, we can go by the what? By this formula. Since we can go with this formula, now let's do it together. So now the moment is equal to the ij components. We're having I here. So let's bring this to the top so that it can easily be done. So I, then we have our j, then our lastly have the key. So let's arrange that. So what's our I form? So you're having positive 0.3 here. Then the next one we are having what? We are having our 0j here. Then lastly, we are having our k to be what? Our k to be 0.08 here. Then now we can easily put our forces over here, right? Because from this, we said that the force over here is with Fx, Fy, Fz. So since we know that, we can easily now bring them. So what's our Fx here? So Fx becomes negative 120. What about Fy? Positive 96. Then our K to be our negative 128, right? So now once we know this, we can easily do by the approaches by cancelling some of the what of the components over there. So since we can easily cancel it, so let's put it there. So now our moment, all right, is equal to, so we cancel this, we lie between this and this and this and this. So we are going to have over here, all right, so this will go, all right, so this I go, this one will go, so 0 times this will give us what? 0 here, then minus, then we have 96 over here multiplied by what? By 0.08, in which we are going to get what? We're going to get 7.68. Fantastic, right? Then we bring what? The I over here. Then the next, we cancel the J. So from this, so this 0.3 is going to multiply this. So let's see. So 0.3. Now this is off. So this goes off. This goes off. So how do you go? So I think for this, we can even use different colors in doing them, right? So let me, for instance, let me use blue for the first one. So if it is I, so this goes, this what? This also goes. So this line between this and this. So with the I, we are using blue. Then let's go for the what? Let's go for the J by using what? By using yellow. So let's see. So I'll go by this, then go by what? By this. So that means this one too is not part of it. Do you understand? So that means at this point, we're going to have over here, okay, that is 0.3 multiplied by what? By negative 100 and what? 128 over here. Then minus, then once you have the minus here, don't forget there is another minus again, right? So minus 120 multiplied by 0.08 over here. Then now we are having our J. Then lastly, you're going to use our key to be our in a green form. So this and this will also go away. So lie between 0 point this one here, right? So that means at this point we can now say that um we can say that now our k two here is going to be our 0.3 here multiplied by what? By 96 here, then minus, so minus here, so 120 multiplied by what? By 0 here to as well. So that is it. So at the end, we are going to have our moment to be equal to, so let's see, so 0 minus 7.68, we're going to have negative 7.68 I here, then plus, now 0.3 here multiplied by what? By 100 and negative 128, we're going to get minus 38 point what? Point 4 here. All right, then minus minus becomes positive. So that means positive 100 and what? 120 multiplied by 0.08, you're going to get 9 point what? Point 6 at this point. So 9.6 at this point. In the whole of this is going to be in terms of what? Of J. All right. Then lastly, we're going to have the K2 as well. So 0.3 multiplied by what? 0.3 multiplied by 96. We're going to have positive 28.81 8k. Now we can easily write them very well by bringing this to the top. So now our moment is now equal to, in terms of component form, negative 7.68i. Then you're having negative 38.4 plus 9.6. You're going to have minus 28 point what? 8j, then lastly plus 28.8k. So this is intention component. So if you want to find the main magnitude of how the moment will be, you just know, just find the square root of them, right? So maybe here with negative 7.68 all squared plus the minus 28.8 all squared. So make sure you bring this. Then plus 28.8 to all squared. So if you're supposed to find the main one, then the moment become 41.447 Newton meter. But in terms of the main um, main vectors or main component form or in Cartesian form, that means you're supposed to leave it in what? In this form. Don't forget your native Newton meter over here. So thank you very much for having me and have a blessed day. Bye bye.